Okay, this is going to be the review for the exponents unit for unit 6. Okay, we'll try to go through the exponent rules as we go here. Okay, all right. So the first thing you want to make sure that you do is that each part has a coefficient, exponent, good. So this is multiplication. So what I'm going to do is I'm going to multiply, okay, the 7 and the 4. So I'm going to multiply the coefficients, which gives me 28. Okay, so I multiply the coefficients, and I'm going to add the exponents. Okay, so the exponent for x is 15. Okay, you can only add the exponent for x over here, which is 2. Okay, so you add the like ones. So that's 17. And then for the y's, it would be 9 and 2 I'd add. It would be 21. So that's x 17, y 21. Okay, and then that's going to be my answer. Okay, so if I look at the second one, I got to make sure I put a 1 right here with A, and I got to make sure I have a 1 right here with B. Okay, so what I'm going to do is I'm going to multiply the 2 and the negative 8, which is negative 16. Okay, and then I'm going to add the A exponents, 1 and 7. Gives me 8. 2 and 1 for B gives me 3. So I have A8, B3. And that would be my final answer. Okay? All right. Here, all right, I got coefficient, all right, base exponent, coefficient, base exponent. That's great. Okay, so what I'm going to do is I'm going to multiply the negative 10 and the negative 8. Okay, so I get 80. Okay, I'm going to add the exponents for M. That would be 12 plus negative 14, which is negative 2. And then I got 9 plus negative 4, which is 5. So that's M negative 2, N 5. Now, I think I'm done, but this is one thing that I have to do. If I have a negative exponent, what's going to happen is that is going to go underneath and become positive 2 for the M exponent. The N 5 stays up there, okay, on that part. Okay. Let me do 4, and then I'll go up to 8, 10, and 11. Okay. So this is the power rule. What the power rule says is I have to put, first of all, I got to put a 1 where the for an exponent of 2. This is only for the power rule. That already had an exponent. Then I'm going to take these exponents. So I put a 1, all right, for the exponent, for the coefficient. So here are the steps for that. Okay. I multiply inside exponents by outside. Inside exponents by outside. Exponents. Okay. So in this case, I would do 1 times 7, 5 times 7. So I get 2 to the 7th power, x to the 35th power. Okay. Then I got to calculate the coefficient. This is the most important step. This is 2 exponent 7. It's not 2 times 7, it's 2 exponent 7. So that's going to be 128. So I got 128 x 35. Okay? Let me skip up to here just so I don't have to scroll all the way down. Okay? All right, so coefficient, exponent, this needs an exponent. Coefficient, base needs an exponent. Okay? So what I'm going to do is, this is multiplication. So I'm going to multiply 12 times 5, which is 60. I am going to add the exponents for x, which are 2 and 1. I'm going to add the exponents for y, which are 1 and 7. So I got x3, y8. And that would be my final answer. Okay? This is multiplication. Once again, I got coefficient, exponent, exponent for that base, coefficient, base, exponent, okay, good. So then what I'm going to do is I'm going to multiply negative 2 times negative 9, all right, which is 18. I'm going to add the exponents for x, so that's going to be negative 4 plus 15, which is 11, and 8 plus negative 8, which is 0. So I got x to the 11th, y to the 0. Now, I think I'm done, but this is one of my finishing rules. If I have the y to the 0, that goes away, so I am left with 18x to the 11th, okay? Here's the power rule. What I want to do, I got a coefficient, base exponent, base exponent. So I want to put a 1 right there where 4 is, okay, this is a 7, okay? I want to multiply 5 times all those things. So 1 times 5 for that exponent, 7 times 5 for that exponent, 2 times 5 for that exponent. So I got 4 to the 5th, x to the 35th, y to the 10th, okay? Now, I have to calculate that. What that is 4 caret 5, which is 1024, x 35, y 10. And that's going to be my answer for this one, okay? I'm going to go ahead and scroll down because that's actually going to take me a little bit more room to do, okay? All right, so... All right, I'll come back to that one. Let's work our way this way. Okay, so what I have to do here, all right, I got a base, I got a coefficient, I've got a base, that needs an exponent. Okay, now, since this is the power rule, I am also going to put a 1 right here. Okay, all right, and the power rule says I take the outside exponents multiplied by the inside. Okay, so what's going to happen is that's 1 times 3, 1 times 3 for the other one, and then 4 times 3. Okay. So what I got is negative 5 to the 3rd power, m to the 3rd power, n to the 12th power. Okay? Now, I have to calculate my coefficient. What we have to be careful of, anytime you have a negative number with a power, go ahead and put a parenthesis right there. Okay? That way you ensure that you are correct with your answer. In this case it would be negative 125, m cubed, n to the 12th. Okay? All right? Okay, now, this is division. So when we do division, we're going to divide the coefficients, and we are going to subtract exponents of like bases. Okay, so I'm going to do 18 divided by 3, which is 6. I am going to do subtraction, 10 minus 8, 7 minus 2. Okay, I got x squared, y to the 5th, that is complete. Okay, this one I'm going to do division, 18 divided by negative 30. I want to get myself a fraction here, so this is negative 3/5. So negative 3/5, I want to get a fraction. Okay, I am going to subtract the exponents for x, that's 7 minus 10, and then negative 8 minus 5. So I get an answer of x is negative 13. I'm sorry, x is negative 3, y is negative 13. Now, looks like I am finished. However, since those have negative exponents, okay, what I'm going to do is I'm going to move the x to the bottom, it becomes positive 3. I move y to the bottom, it becomes 13 next to 5. Okay? All right, and that's how I would do that answer. Okay? All right, so here are probably the 3 hardest of all the power rules. Okay? All right, what you want to do here is focus on this part first. All right, first of all, this x would need a 1, okay? In the power rule, just for this, I got to put a 1 right there also with the 2, okay? So I'm going to multiply inside exponents by outside exponents, okay? So 2 times 1, I'm sorry, 1 times 4, 1 times 4, and 9 times 4, okay? So what I got is 2 to the 4th, 2 to the 4th, x to the 4th, y to the 36th. Now, the next step in this is to calculate the coefficient. 2 exponent 4 gives me 16. Okay, so 16x to the 4th, y to the 36th. Now I have to apply that to the negative 3. So I'm going to take that result. So it's like I'm starting the power rule all over again. I got to put a 1 right here. Okay, and I'm going to multiply. 1 times negative 3, 4 times negative 3. Okay. 36 times negative 3. Okay, so I got 16 to the negative 3, x to the negative 12, y to the negative 108. Okay, I am going to want to calculate what 16 to the negative 3 would be. Okay, I have to hit the fraction of decimal button. Okay, so I get 1 over 4,096. Okay, this would be x negative 12, y negative 108. Okay. Now, once again, my rule states that those have to come down next to the 4096 and become positive exponents. So that would be my final answer. Okay? On number 12, what I'm going to want to do is handle this part first. Okay? So I got to put a 1 right there for the power. So I'm going to multiply all of those 1 times 0, 3 times, whoops, 1 times 0, 3 times 0, negative 2 times 0. So I got 5, 0, x 0, y 0. Okay? Now, all right, I got to figure out what 5 to the 0 power is. That is 1. So this bottom part is this. Now someone's going to say, Mr. Evans, can I do the finishing rule? No, because we're not really done with the problem yet. So what we have here is 60x to the 5th, y to the 11th, over 1x 0, y 0. So now I have division. So what I'm going to do is I'm going to divide 60 divided by 1, which would just be 60. Okay? And then I'm going to subtract the exponents. 5 minus 0, 11 minus 0. So the exponent for x is 5. The exponent for y is 11. And that's my final answer. So I didn't have to do that back there. You only have to do the 0 power, okay, and the negative exponents when you're finishing the question. Okay? So here we go. Number 13. I am doing division here. So that is, I'm going to do this inside part first. So 10 divided by 15 as a fraction would be 2/3. Okay? So I'm going to have 2/3 as a fraction. Okay? All right? I would do 22 minus 9. I get x to the 13th power. Okay? Actually, don't put it like that. X to the 13th power. Now, what I have to do is I have to do that to the 4th power. Okay? 2 ways you can do this. Okay? First of all, since it's the power rule, I would have to put 1 with my coefficient. Okay? All right? Now, I'll show you 2 ways. If I treat that 2/3, okay, like its own coefficient, okay, that would become 2/3 to the 1, and then x to the 13th, all right, all raised to the 14th power. I'm sorry, the 4th power. Okay, so 2/3 times 4, because 1 times 4 would be 2/3 to the 4th power. 13 times 4. Okay, so I did 1 times 4 there. Sorry, 1 times 4 gave me to the 4th power there. 13 times 4 gives me 52. Okay, all right. Now I would calculate 2/3, parentheses 2 divided by 3, raised to the 4th power. And if I do the fraction of decimal, I get 16 over 81. And then the x 52 would just join right next to it. Okay. I saw somebody else suggested this. Mr. Evans, what if I did it like that? Okay, and I did. See if I can move this down a little bit. If I did 2 to the 4th, if I did 2 to the 4th power, okay, it's a little too far. And then 3 to the 4th power. I treated these as individual exponents. So when they got raised, I multiplied them. That would work too, as you can see. 2 to the 4th would be 16. 3 to the 4th would give you 81. So either way you want to get there is fine. Okay? All right? Now, this is polynomials. This is multiplication. So what I'm going to do is I am going to make a box. Okay? Since there are only 3 terms here, 4x squared. Okay? I'm sorry, that's not right. Hold on. Okay, make a box. Okay, 4x squared minus 2x plus 5 is what I am multiplying. And I am multiplying it by 6x. Now, this is like doing a bunch of little mini polynomial stuff. So I'm going to put a little 1 right there. So I am doing multiplication. Okay, so I am going to multiply the coefficients and add the exponents. So 6 times 4 would be 24. I am going to add the x exponents. So 2 plus 1 is x cubed. Okay? All right, now this one needs a 1 as well. Okay? So I got 6 times negative 2 is negative 12. Add the x's, 1 and 1 is x squared. All right, and then 6x times 5 is just going to be 30x. Okay? All right, now, as you can see, all those terms are different, So I can just write those like this, and I am finished, because none of those can combine. Okay? This one, there is only two terms that I'm multiplying. 5x squared, negative 4x. I put this negative 9x here. Okay, once again, since I have variables, that's got to have an exponent, that's got to have an exponent. So what I'm going to do is I'm going to multiply, so I'm multiplying the coefficients, negative 9 times 5, which is negative 45. I am adding the exponents, which is 1 and 2, which is 3. Okay, then I am multiplying this, I'm going negative 9 times negative 4, which is positive 36. And if I add 1 and 1, it would be x squared. As you can see, these terms are both different, so there's nothing to combine. And so that would be my answer. Okay? Now we're going to multiply two binomials. Okay? So I got two terms. This will be 10x minus 7, 3x plus 8. All right, I put a 1 here and a 1 here. Okay? So this first one, the first part of the box is 10x times 3x. So 10 times 3 is 30. If I add the exponents, that's 1 and 1, which would be 2. Okay? Negative 7x times 3x, you can just multiply that in your calculator and just make that negative 21x. 10x times 8, so 10 times 8 is 80x. And then negative 7 times 8 is negative 56. Now, if you look throughout your box, you will notice these two terms are alike. So with like terms, I type them into my calculator just how I see them. Okay? And how I see them is negative 21 plus 80. So that middle term of 59, okay, that will be my middle term of positive 59. The 30x squared is just out here, and the minus 56 is out here, because those are not like terms. So these two terms right here are what I had to combine in my calculator. Okay? All right? I'll get to the other one right here. This is simplified. Now, what we want to do with this, okay, I want to put a negative 1 here, and I want to distribute that. So I got 10x minus 7y. Negative 1 times 8 is negative 8x, okay? And then negative 1 times negative 2, all right? I just put a 2y here. Now when I look at this, this will combine with this will combine with this. So what I'm going to do is 10 minus 8, which is 2x. Then I will do negative 7 plus 2 is negative 5y. So when you're combining like terms, when you combine like terms, all right, all we're doing is adding them and subtracting them in the calculator like we see them. Okay? All right, do not change them. So on this one, I want to put a positive 1, and I want to distribute that. So I still have 9x, still have y, which I would put as 1y, minus 4, that, I would put a 1 here, okay? All right, so 1 times x squared would be 1x squared. 1 times negative 4y would be negative 4y. 1 times negative 9z would be that. If you want to put exponents for those, that is fine. I have no problem with that. Now, so when I go to combine like terms, there is no other term that combines with the x. Now the y's, this one and this one will combine. So that would just be 1 minus 4. Now if you notice, I am not changing any of the exponents. Okay? Alright, so when you add or subtract, you're doing that, or I'm sorry, when you're combining like terms, don't change the exponents. Don't change exponents. That's really important. Okay? Then I got negative 4z, and I got negative 9z. Okay? So negative 4, okay, minus 9 is negative 13z. And this didn't have a like term, so that's just going to stay right there. Okay? Let's move down here a little bit. Alright, so we're doing more multiplication. So I got two terms. Okay, so 2 terms by 3 terms. Okay, I'm going to put a 1 for that exponent, 1 for that exponent. So once again, back to multiplication. All right, 2 times 3, okay, 3 times 2 would be 6x. If I add the 2 and the 1 and the 2, I get 3. Then I'm going to do this times this. Okay, so 3 times -7 is -21. If I add the exponents there, I get x squared. 3x times -4. All right, since the -4 does not have anything. Okay, all right, I got -12x. Okay, then I'm going to do -5 times 2x squared. So this is -5 times 2. So nothing's going to change with the exponents, -10x squared. Then I got -5 times -7. So that's +35, and the x is going to stay there. -5 times -4. Okay, this is 20, +20. So, if I look through here, the x cubed does not have any like terms, so I can just write 6x cubed. Now, if you see, these two have the same, are like terms. So I am going to do -10 minus 21, and that gives me -31 for the x squared. So inside the boxes, we're combining like terms, okay? Then I got 35 minus 12, which would be +23x. And then the 20 is by itself, so that's going to stay like that. So that will be your answer to that problem, okay? This, what you should do, this is basically meaning this times this, okay? So I got 2 terms, so I got to make a box, okay? All right, I got 7x minus 3y, 7x minus 3y. So that's how you make the box. Just write out the terms, all right? Draw lines between them. Draw lines between them, you get your correct number of boxes. Okay? I am going to put a 1 here. I am going to put a 1 here. I'm going to put a 1 here. I'm going to put a 1 here. Okay? So the way this works is 7 times 7. That's going to be 49. And if I add the x exponents, I get 2. Okay? Now if I multiply these, I'm allowed to multiply those. 7 times -3 is okay. That's going to be -21. And since it has an x1 and it has a y1, so I just put those next to it just like that. I do the same thing here. -3 times 7. -21. I have an x. We'll keep the alphabet the same. All right, so I kept it in x-y order. Okay? Then I got -3 times -3. So I got +9. Now I got y and y, so that's going to be y squared. Okay? So if I look through these, the 49x squared is good. There's no like term there. These are like terms, so I type those in the calculator just like I see them. -21 minus 21. No extra signs. Okay? No extra signs. So that's going to be -42, x1, y1. And then this is going to stay just 9y squared. Okay? All right, going on to the last problems, some scientific notation stuff and some classification stuff. Okay, all right, the scientific notation, let me make sure you can see that. Yeah, you can. Great. So we're just going to use our calculator here for this. So that's going to be 7.3 times 10 to the 11th power, close the parentheses, that's 12 times 18 times 10 to the 18th power. Okay, now, what this means is, I have 8.76 times 10. This is always going to be here, okay? And what this E means, what that E means is that's prompting you for that, and that means that exponent is a +30. Okay? Now that one's hard to see, but that is 7.9. Okay? What you're going to want to do is put this in parentheses up top. 7.9 times 10 to the 4th power. Close your parentheses. So I want to do parenthesis here, okay? Divided by parentheses 3.8 times 10 to the 27th, okay? Now, once again, I got 2.07. That E prompts me to do to the 10th power, and that -23 means my exponent is -23, okay? To write in scientific notation, I just start this, I move it 1, 2, 3, 4, 5, 6, 7, 8. Okay, okay? So I want to move it, I move it till the number is between 1 and 10, okay? All right, so I moved it 8 spaces, so that's 10 to the 8th, okay? This one, they give me the decimal, 1, 2, 3, 4, 5, 6, okay? So it's 2.87 times 10. When I move this way, though, the exponent ends up being negative, okay? Write the following in standard notation. That's pretty easy. All we're doing is just multiplying that out, okay? What that means is if I have 9.86, I can just move it 1, 2, 3 spaces. So there's zeros now in between that. So this would be my answer, okay? Same thing here, all right, 6.53. All right, so I'm going to move this 5 spaces, 1, 2, 3, 4, 5, okay? So that's going to be 6, 5, 3, 0, 0, 0, 0, okay? All right, so basically just like working backwards, okay? Move it back the way it came, okay? All right, it says, write the following expression in standard form, combining any like terms, okay? So the only terms that are alike here are, I don't want to do that, circle that too big, okay? Are this term and this term. So I put a 1 there, you can put 1s if that helps you, okay? So the only like terms there are -3 minus 1. So basically that's going to be -4x, okay? Now, to put it in standard form, you put the biggest, all right, standard form means biggest exponent first. So I'm going to do -10x to the 7th, because that's the biggest exponent. Next biggest exponent is the 5 exponent. The next biggest exponent is the 4, and the last one would be the x. So that's what it would look like in standard form, okay? All right, moving on to the last couple questions. Okay, all right, it says classify the polynomial by degree, number of terms, and then the degree. All right, so a monomial would be 1 term, okay? A monomial, let me give you some examples. A monomial is like the things we have when it's like this. A binomial is when there is an operation between those 2 terms. A trinomial means there's 3 terms, and poly just means plus. So like more than 3 terms, more than 3. Okay? So in this case, I got 4 terms, so that's going to be a polynomial. Okay? A constant function is just a number. A linear function is just something with x. A quadratic is something squared. A cubic, let's change these so you're not getting confused here. Hold on. Got a little paradigm. I don't want you to create a paradigm here. Okay? Like here would be an example of a linear. Here would be an example of a quadratic. Okay, so it refers to the exponent. A cubic, that's the exponent of 3. A quartic would be an exponent of 4. And a quintic would be like an exponent of 5. So it refers to the exponent, the biggest exponent. So the degree is the biggest exponent. So the biggest exponent here is 4, so that is a quartic function, okay? If you practice these exponent rules, they do take some practice. If you do practice them, you'll do well.